All right, thank you, Michael. Mic works? Yeah, cool. Okay, so yeah, my biggest achievement has been the last 2 years I have not gone to the Chi conference and yet have won the most popular tweeter competition, which is a real thing. So I'm very proud of that. So for the last 15 years or so, I've been working in this domain of accessibility, which I think is really interesting. I think it is really well connected to kind of AI and machine learning, especially as we develop interactive systems and think about, well, how are people really going to use and benefit from what we develop within machine learning? And so today I'm going to take basically 2 sections of a talk. So the first talk, I want to introduce you to kind of how I've come to think about accessibility as a field. And then I'm going to apply some of the lessons from that in AI and machine learning to hopefully convince you that they're connected, and also hopefully convince you that there's a really big opportunity right now, I think, to apply what's happened in machine learning over the last few years to accessibility. And I'll give you some examples about how I'm thinking about that. All right, so first, a bit of an introduction to accessibility. So whenever somebody gives a talk on accessibility, they inevitably have a slide that's kind of like this one that says things like over 15% of the population has a disability, so accessibility is really important. You have, or probably will have, if you're lucky, a disability sometime in your life. As you get older, many people develop what is essentially a disability. And having walked around a little bit on the Stanford campus, I can tell you that there's a lot of people experiencing what we would call situational impairments right now, looking down at their phone, walking, maybe driving, riding the bikes with their phone and whatever else you're trying to do. I think that's really important too. But I really push back on this notion that accessibility is niche, that it's kind of this narrow thing. I think accessibility is very big. And so this little dot, which I just had there and didn't explain, is not accessibility, right? So this is the narrow set of interactions that we assume with our devices that everybody has, maybe high visual acuity and high motor dexterity. And everything else is essentially accessibility, right? So getting you to be able to interact with any other set of abilities is kind of in this domain of accessibility. And so for me, accessibility is very intimately tied to human-computer interaction as a field, right? And so if we look at some of the really great, innovative, important developments in HCI over our history, what we see is not only the introduction of really amazing new interaction possibilities. So for instance, Engelbart's mother of all demos, right? This is kind of what gets a lot of us in HCI super excited, and I'm super excited about it. At the same time, what happens when you introduce a mouse and you introduce a visual display and the graphical user interface? What you've done effectively is lock in a set of abilities that then we assume going forward. And that's really important. It was actually really important that we did that to make deep, sustained progress in HCI, and it's been wildly successful. At the same time, these are ability assumptions that accessibility has to deal with, and it keeps happening, right? So, another really amazing development in HCI, introduction of the iPhone.
We're going to use the best pointing device in the world. We're going to use a pointing device that we're all born with. We're born with 10 of them. We're going to use our fingers.
All right, so introducing an iPhone, right? Use your fingers. Amazing new kind of interaction with our mobile devices. It works really, really well. At the same time, not everybody can do that. And so, one way this has sort of been humorously illustrated is with this kind of, maybe you've seen this little figure or these kinds of figures before. You have this, how does your computer see you? And like in this case, this is a little person here with one giant finger with presumably high motor dexterity, one eye that can kind of see flat surfaces, some ears that maybe you listen with. So one way I've started sort of jokingly, but somewhat seriously referring to this is, these sort of ability assumptions are HCI's original sin, right? This is what we've sort of been working against in accessibility now for years. And so accessibility, one way of thinking of it is accessibility is the long slog against ability assumptions. So we've locked in this set of abilities. How do we develop devices that work in different ways? So some things that accessibility cares about, so the grand challenges of accessibility. We care about expanding into new modalities, right? And there's lots of people working on Well, let's say someone can't use a touch screen, someone can't use a keyboard, can't use a mouse. What other kinds of modalities can we use? So tactile input, for instance. I got to see some really great examples in Sean's lab. The other is, for better or worse, we do have all of this stuff out there that assumes certain abilities, and so we need to be able to translate between it. And I'll go into a little bit more about why that is. But if we have something that is assumed to work in one way, how do we make it work in a different way? As we develop more and more features, so I think it's really great that a lot of devices, like the iPhone has 50 accessibility features that change in all kinds of different ways how you use it. But how do people know about those, right? Do people know like what set's going to work for me? And then even if we come up with really great solutions, there's this immense legacy problem where all this stuff is just out in the world. Like, I don't even know, I haven't actually played with it, but like there's a whole panel in front of me, right? This almost certainly isn't accessible in all kinds of ways. Are we going to replace every single panel, replace this panel, replace all this stuff? There's all these books that are printed that everyone's lost the digital version of. Lots of legacy problems out there. So how do we deal with that? So when new technology is introduced, one thing we do in accessibility is kind of race to figure out, well, how are we going to make that accessible? And so this is kind of an old example, but I really like it. It's a project that I worked on with Sean Kane and Jake Wabrock when I was at the University of Washington about 12 years ago. And the idea here was that the iPhone had come out, and we really wanted to be able to use it non-visually, right? So at the time, there was no screen reader on it. This is all changed now, but how are we going to do that? And so we developed this system called Slide Rule. I'll play a video of it working. Takes a second, I think. We're going to open up this Slide Rule app, and now we're in a completely possible to use non-visually mode.
Phone book, mail, music, phone book, mail, music, phone book, 10 contacts. A. Alec Baldwin, 1 of 10. A. Audrey Hepburn, 2 of B. Bill Cosby, 3 F. Frank Sinatra, J. Jason K. Nicole T. Tom Woody Allen, 10. Calling Woody Allen.
Well, so the couple of things that this does, right? So it repurposes this touch screen as a touch-sensitive surface. It allows you to explore with your finger. And importantly, it introduces this idea of risk-free exploration. So now moving your finger around doesn't activate things. It allows you to hear what's under your finger. And then we use a second tap to actually select that thing. One of the other things we noticed is once you are freed from this visual space of the existing graphical user interface, you can actually fit a lot more stuff on there. So I don't know if it was obvious, but when he was going through the phone book, each item in the phone book is now the pixel or the input resolution as opposed to the visual resolution. So you could actually fit a huge phone book on a single screen as opposed to having to scroll around. Anyway, so this was really fun. And it's just an example of how do we adapt or how do we think about like using some of these devices in different ways. I have a fun little picture. We just got the Impact Award, the 10-year Impact Award at Assets. And so this is Sean, Jake, and me holding up plaques. Anyway, so now this sort of interaction or some of these ideas from this sort of interaction are available on your iPhone, on your Android phone. And it's embedded in a program we call a screen reader, which allows non-visual access to an otherwise graphical user interface. And so it's got this name, screen reader, because at least initially in the development of screen reading technologies, the idea was that people would build software and would literally intercept the pixels that were being written into the screen, and sometimes into the screen buffer. Sometimes they were able to get it before it was turned into pixels, like text before it got turned into pixels. And it would then convert it to speech, as you'll see here in a second, or refreshable Braille. So not all assistive technologies are screen readers, but I do think it's really helpful to think about, well, how does a screen reader work? Because some of the ideas translate.
On. Round trip.
Oh, it already played
One way.
Okay, well, here's
Round trip.
a screen reader reading
Round trip. One way. Pit.
this Delta app,
Text.
which
Saturday.
I use a lot.
January.
So at a high level, right, it comes up with some sort of representation of the graphical user interface. If you've ever built a web page, you might think of this as sort of the DOM of the user interface, and then it traverses it. If it's a tree, then it's a depth-first traversal of the tree. Just has a question.
Shows the focus of not all assistive technology, but a lot on, changing the GUI to voice, a result of just that transitioning from a textual interface to a GUI cut off a lot of visually impaired people who had found employment in that area because it actually fit some of their skills better? Or is it due more to this is the biggest different ability in the population or easier to attack? Like, I'm curious whether, obviously as people age, we start to see people getting worse and worse vision, so it's kind of broader than just, let's say, low vision blind people, or are there other, motor and other impairments that are bigger?
Yeah, so this is a really good set of questions. So one is, why do we focus, or why am I talking about screen reading? One reason is because I think it's one of the quickest to understand of, you've got this graphical user interface. Usually you don't have to convince people too much that a person who's blind can't see that. And then thinking about, well, how do you convey that information? And you've got this underlying representation, and you have to somehow convert it to voice. Many of the other kinds of accessibility features that you might have, so I mentioned, however many on all your devices, work using many of the same underlying things, right? So if I am somebody who is a switch control user, for instance, who I have a set one or more switches that allow me to go through the user interface, it works actually in a pretty similar way, where instead of voicing things, it visually shows me a progression across different possible user interface elements, and then I can choose how that progression goes, and I can choose which one I want to select. And there are others, right? So we obviously there's ways to change how touch works, what kind of motor dexterity assumptions there are. There's endless features for magnification, for changing colors, for doing all of these sorts of things. So there was a big switch from when there were text-based interfaces, like command line interfaces, where there was obviously still some problems, but it was a little more straightforward to create like a screen reader experience for a text command line interface. When you go into graphical user interfaces, at least initially, a lot of the semantics were just gone in pixels, right? And there's been decades now, I think, to reverse some of that, where you have access to a better representation of the GUI that you can convert to different forms. I think the reason why we focus a lot on GUIs is because this is still the dominant way that things are represented, right? And you find a number of examples out there where you could imagine, well, let's create a whole separate web page, and people do this, and it's always a bad idea. Create a whole separate website for people who are using screen readers, for instance. This happens, actually, this is Blackboard's solution for accessibility. Almost always it works differently. You have access to different stuff. And so the trade-off that people have been willing to make, and I think it's important and it makes sense that they make it, is to put up with these transformations, because at least that gives you access to the thing that everyone else has access to, and that most of the focus is put on. Yeah?
I'm curious, has anyone ever tried to sort of discuss or measure like what you could call like an accessibility gap? Like, imagine that you give me this Delta app, and then you also split me into a parallel world where you give me the blacked out version of it, you train me on the screen reader, and I get highly trained with it, and then you're comparing me on, say, a number of tasks. Like, you look at the delta in terms of number of errors I'd make or how long it takes me to get something done. Like, do we know like how big that gap actually is?
Yeah, well, I have some slides for that. So maybe I'll just skip ahead to this a little bit. So one of the big problems, right, is that none of this works unless you have a good representation, right? And so I have some slides about that. Let me actually, I'm going to get back to your question, because yes, there's a difference. There's a lot of people who looked at it. It's basically worse, right? But I can quantify that a lot, yeah. But I'll get back to that. I do have some slides on that. So one of the challenges is that there are just these persistent problems in creating that representation that any of these accessibility tools can actually work over, right? So one of my first projects in graduate school was a project that looked to try to make the images on web pages create an alternative textual description for them so that the screen reader could read them, right? I think this is the UCLA website, and basically all of the text and all of the navigation information on this website were images, and so the screen reader had no idea what they were. And so we came up with a number of approaches to try to fix this. Interesting thing is, flash forward to 2020, and we're still using images across, the web and our mobile devices. Michael mentioned I use Twitter a lot. A lot of people share images on Twitter. Up until about 2 years ago, you couldn't even add an alternative text description for images. Now you can. So there's a little button now if you go there. The amazing thing, we crawled over 9 million tweets. The joke is we were going to write on this little bar like how many of those image tweets had alt text, but you couldn't see it if we did that. And so we had to blow up this little area into this big box, and that black dot is the 1,000 of the 9 million tweets that actually have alt text, because no one does it. Why don't they do it? Well, lots of different reasons that we got into in this paper. But one of them is that Twitter made an interesting design decision. So you don't just automatically get access to this alternative text option. You have to go through a process. It looks like this. So 3 menus down, you can turn it on. And then what that means is that you now have the option to provide an alternative text description if you choose to do that. There's all kinds of problems after that, right? But basically no one gets past this step. And so people still don't necessarily write good alt text descriptions, and they don't know how to do it and all these things, but most people don't even know about it. Yeah.
We know a lot about defaults and user interfaces and what that does in organizations. Given your co-author on that other paper, do you have ideas of what the political issues were for Microsoft turning it on? It seems automatically in PowerPoint, like it prompts me to do alt text, versus Twitter not making it easy in that way.
Yeah, I think that there's a lot of things going on, many of which you might guess. I don't know exactly what happened within Twitter. We, of course, have tried to ask them and not gotten so far. And they're doing better now. I think this paper and maybe some other pushback, they are doing a little bit better. It's not on by default yet for everyone yet. But one thing I've come to learn, having kind of straddled academia and industry and accessibility for a while, is that the way accessibility actually happens in an organization is when that organization decides that accessibility is a value. It doesn't mean just hiring an accessibility team if they're not empowered to make real change. It doesn't, unfortunately, mean that even well-meaning individuals who maybe knew that this wasn't, Twitter has an accessibility team, right? And they know this is an issue. But how do they get empowered to make changes, right? And you might speculate, well, why wouldn't they want that little add image description button on the tweet? People might think it's, well, what is that? Is that will that confuse people? The cynic in me, if you follow me on Twitter, the tweet would be something like, they probably did an A/B test and 0.1% of fewer tweets were sent. And so they decided they'd rather have 0.1% of alt text provided, right? But I don't know. But I do think that if it's not a value, it doesn't get done. And so you look at the companies that do well in accessibility, and they usually do have a real value behind it. To Michael's point, and this kind of all feeds in with each other, right? So there's kind of this notion, and this was first expressed to me in this way by T.V. Raman, who's a blind scientist at Google. This idea of first and second class abilities, right? So first class is the ones that sort of we see by default. So you see high visual acuity, you see high motor dexterity. And then you get stuff added on. And it's possible to use, but it's never quite as good for a lot of different reasons. It's hard to make it good. If you've designed it one way and then someone comes along and they can't have access to everything, not every experience gets to be designed for every single modality. Those other ways are just not as good. So to Michael's question, right, has someone studied? So we did a study. I won't get into all the details, but across different tasks on the web where we controlled, if it was designed to be an easy task, a hard task, an inaccessible task, or an impossible task, which is, I'll explain. Basically, the blind users took between 2 and 3, 4 times as long to complete the task. And one outcome of the task was deciding that it was impossible, right? And so one trick there, and one of the points of the paper, beyond just demonstrating that it takes longer, is if something's inaccessible, it can actually be pretty confusing to know, is it inaccessible or unavailable, right? And so the title of the paper is, the effect of not knowing what you don't know on web accessibility, because if I go to a web page and I'm looking for, a phone number of a pizza shop or something, and it's really hard for me to know, is the phone number not there, or is the phone number, expressed in an image or a flash application or something else that just doesn't work. And so we were looking at that. Another thing that I think is just interesting in bringing up these points in accessibility is, sometimes we're in this kind of related, awkward position of designing what users don't want, which is really anathema to HCI. And so one example, just a quick story of where this came up for me. So a few years ago, we recognized, there's all of these speech-controlled devices coming out, both sort of the platforms like Alexa and Google Now and Siri and all these things, but also, at the time especially, it wasn't quite consolidated, and so there were all of just these random things you could get that were speech-controlled. Like we found like light bulbs and like appliances, like your microwave would have its own like speech recognition chip on it. And I started thinking, based on kind of this history that I've led you toward, well, what's going to happen when these are just out in the world, right? There's going to be people who can't speak and be understood by these devices who are put in situations where that's the only option, right? And it is the case now. There are some hotels, I think the ones I found here are here in Silicon Valley, where your hotel room is speech enabled, so you can turn the lights and the thermostat and whatever when you get to the room. I don't know offhand if there's an accessible way. Maybe you get put in another hotel room that hasn't been updated recently that's accessible. I don't really know. But anyway, so these things are not accessible, right? So Alexa, I'll pick on because there's not been a way to alternatively control Alexa. So with things like Siri, you can type to it. Google Now, I think you can type to it. And so I looked at that, and it's like, oh, this is a big problem. We did some work on, in this case, we were targeting people who were deaf, who had a characteristic deaf accent that's not understood by these devices. And we explored different ways. I think there's really interesting work happening in different places. Like Google has a big project now on atypical speech, looking at could you actually make speech recognition work for all kinds of different types of speech. But at the time, that seemed pretty far off, and it was really hard. And so I had this idea of like, well, what if we just had like your phone? Like your phone could produce text to speech. So Alexa doesn't support type to Alexa, but like if your phone could convert text with text to speech, it could talk to Alexa, it could turn on the light bulb or whatever, and then Alexa could talk back, and your phone could recognize that speech with speech recognition, and at least you'd have a way to do it, right? So great. And there's like kind of interesting interaction challenges there too, because you don't know, like if I'm typing something and it gets spoken out, like I don't know if it spoke the right thing, if Alexa understood it, Alexa says something back, I don't know if like what it actually said is what I got. So there's kind of these different things. And so I put together one of our master's teams to kind of explore this problem, right? And then I connected them to people local in Pittsburgh in the deaf community who could be potential users of this thing. And the immediate feedback was like, why would we ever want that? That sounds terrible. This is like, why would I want to type on my phone to talk to this thing and have that thing talk back and then read it? When all that stuff's going to break, like I want to use sign language, or I want to use gestures, I want to do something else. And I'm like, yeah, I know, but like all this stuff is just going to be out in hotel rooms and places, or your friend's house is going to have this thing, and it's not going to have like sign language recognition, which is an incredibly large, hard, way off problem. Isn't this necessary, right? And it's like in this weird case, I'm arguing basically, ignore your users. They didn't do that, to their credit. They didn't ignore their users, but at the same time, like we didn't have the solution, right? So I don't know what the right answer was here, but it's a really tricky challenge that we come up with a lot, where we're in this position potentially of designing something that users don't want. All right, next challenge, discoverability. So Michael mentioned this screen reader that I built when I was a PhD student. It was this web-based screen reader. The idea is, yeah, you don't have to buy a screen reader. You could access it from any computer, and that was kind of the advantage of it. It sounded kind of like this.
Web Anywhere has loaded. 3 headings, 1 link. Welcome to Web Anywhere. Heading 1, Web Anywhere Alpha Release. Web Anywhere has been initialized. Anyway,
it's kind of fun. I got the chance to build a screen reader. I can tell people I built a screen reader from start to finish, and it's learned a lot from doing that. But in the case of discoverability, my point here is once I did this, we put it out, it got some attention, and I started getting all of these emails. And the emails weren't like, oh, wow, that's really great. I can access this thing on the web from any computer. It was like, oh, wow, I'm so glad there's finally a solution for people who are blind to be able to access computers. And it's like a lot of emails, right? My first experience with, wow, people just don't know about this stuff. And why should they, right? It's not out there. It's not. And we did another project on making content on the web a little bit bigger so that people could see it easier. And we ran a study with older adults, so in this case 55 plus. Only 2% knew how to basically how to do Command plus to make the web bigger, right? So 2%. That's a feature that's on everybody's web browser. And most people would benefit a lot just from increasing the font a little bit. They didn't know how to do it because it's not there. It's like not discoverable. And so there's this huge problem. So even as we develop solutions, some solutions that actually work pretty well, right? Like just making the font size bigger a little bit helps a lot of people. It's on all of your devices. Now it doesn't even matter what device you have. This is on everything. And almost nobody knows that it's there. So how do we fix that? There's these interesting parallels to draw, right? So this is a tactile graphics project that I was not part of, but my advisor, Richard Ladner at the University of Washington, did a lot with. And the idea was essentially there's all of these science textbooks that you're expected to use if you're in any point along your education. And if you want to make that accessible to a person who's blind, you got to convert it to a tactile form, which is some complexity in. You got to make it the right size. You got to fit the braille, all this stuff. But what's amazing, and it was amazing at the time, was that all of this stuff was built with digital tools. And yet, they didn't have access to any of that. And so the standard process was you'd get the physical book, you'd cut the binding off, and then somebody would go through scanning the text. But then for the graphics, it was hard. And so the approach here was basically take the picture of the figure and then run through this kind of human workflow to then generate a tactile version of it that could then be printed. But this is like not changing, right? So one of the things we've noticed recently is, sometimes maybe if you don't want to attribute the source of your retweet, people will take like screenshots of tweets, share them on Twitter. People will always like reading news articles and they'll take a screenshot of that. Or maybe you want to take a screenshot of some part of the user interface so that you can help somebody use it. Again, you've now taken something that, because of all this rich work that's happened in creating that underlying structured representation of the user interface, is sort of accessible, or at least convertible to something accessible, and now you've captured it in a way that's just pixels. And then you've reshared it, making it not accessible anymore. And so my student, Sujith, re-implemented the screenshot tool on Android and then on as part of Mozilla web browser to basically, as you take the screenshot, capture the structured information and then embed it. There's many ways you could do this, but one way is just embed it in the EXIF data so that it's there. And unfortunately, a lot of people will strip the EXIF data off. But if you didn't do that, then you'd still have it at least potentially carrying along. And there's all kinds of clever things you can do to get around that problem, clever things you can do about, like, well, what if somebody later kind of crops out some of the web page or the screenshot that they've taken to remove some private information? Can you make sure that this underlying structured information isn't there anymore? So there's lots of stuff to do with that. What is a human? So this is something that humanity, sort of like what it means to be a human, is kind of embedded in our technology in a bunch of different ways. This applies in the way I'll describe here, but also as we talk about AI and ML. So we started looking at CAPTCHAs. My first Chi paper was about basically CAPTCHAs are terrible, not surprisingly. But what's interesting is that the same thing with first and second class modalities shows up with CAPTCHAs. So people thought, oh, you could just create an audio version of the CAPTCHA and play that instead. So I'm going to play this, and I'm going to give you some hints. So this is a sequence of numbers. There's going to be some background noise, and so the idea is if you can tell me what numbers there are, then you are human. Okay.
1, 7, 8, 2, 3, 4, 8, 5.
Okay. How many numbers were there?
6.
I think there's more like 10. I'll play it again. I'll play it again with the visuals showing too.
1, 2, 3, 4, 5.
Got behind a little bit, but anyway. I've been playing the same CAPTCHA for like 10 years. So to me, I know this one. So I'm always like, well, they can clearly hear this, right? But anyway, so this is not an unusually hard audio CAPTCHA. Obviously, the modality change makes it different, though, right? So like, I can't just keep staring at like the particular part of the CAPTCHA I'm trying to figure out until I reason with myself about what number it is, right? It goes by. It's right. Anyway, so we did the study, and basically the audio CAPTCHAs are a lot harder. Not surprising. One trick, though, like I thought it was really interesting. The interface provided makes it even worse on people.
The audio file is intentionally distorted to prevent
These are like the
automated
instructions.
programs from reading it. If the file plays in another program, remember the numbers, return to this page, and then type them in the field below. Play audio button. Browse off. Play audio button. Audio number, edit box.
So anyway,
Browse off.
just remember those 10 numbers that you can't understand anyway, and then type them in the box later. Anyway, we were able to improve this a lot just by changing the interface. Basically made it so there's not a different audio player, that you could be in the same box to control the audio playback. But anyway, it just kind of keeps coming up, these things. Takeaway here, right? Accessibility is hard. It means a lot of different things. It's this huge space. And I think it gets less attention than it should. It's converting to and from any modality, right? So basically, if you want to accommodate any ability that people come with, you need to be able to convert between modalities pretty fluidly. It's working in an environment that's often not prioritized. It's dealing with a legacy of inaccessible stuff, educating people to use your stuff. How do people find it? And then sometimes it means working hard to develop solutions that aren't as good as what you could develop if you targeted the ability that you're converting to in the first place, which is tricky. So if we now connect this, I'm trying to bridge over to AI here. Perception and action feels a lot like intelligence, and so there are actually a lot of connections between accessibility and modality changes. If it's not prioritized, you need to get everything out of the little bit of input you have, and so machine learning that scales is actually pretty important. Again, legacy, there's a huge amount of legacy stuff. Even if we made everything accessible from now forward, there'd just be so much out there. And so scaling with machine learning is important. Potentially automatic personalization, and working hard to develop solutions that aren't as good. Well, AI is magic, so it'll be great. I'm a little bit less sure about that one. All right, so just a few points, and I don't actually have that much time, so I'm just gonna run through some of these points about where I think these things intersect. So one, I like to say that people with disabilities are often early adopters, the earliest users of technologies that in kind of AI, ML space for real are often people with disabilities. So the people I know who have relied on speech recognition for the longest are, say, people who can't otherwise type. I think that one of the things that accessibility has really taught me, and I think it's a broader point for HCI, is that for lots of reasons, AI/ML people tend often to be focused on kind of iterating with a fixed set of data and then trying to improve models, see what they get out of things. I think there's a huge space that goes beyond that, and a lot of that is not fixing on a particular problem, not fixing on a particular data set, evaluating alternatives, figuring out interaction flows where, yeah, this might work for some subset of people, but what's the fallback if it doesn't? And considering all those things kind of at the same time. And then ultimately figuring out like if what you produce is even something that is worth having, right? Maybe the limitations are so great that it's not. And so I think, I somewhat facetiously, but ML, HCI, right? I feel like this huge part of what it means to really develop and deploy real ML systems is really HCI problems. There's some recent work by Carrie Kai and Philip Guo, talk to people about what do you struggle the most with when using ML frameworks. There's a lot of stuff that it's like, parameter tuning and all this stuff, but one big thing is, when should I apply ML? to what, when will it succeed and when will it suck, right? I think that's an underappreciated but huge part of developing real ML systems. Accessibility has really taught me about, well, what does it mean to develop fair ML? Lots of ways to think about this. I like to have concrete examples. Example in Pittsburgh, we had those little driving robots that were delivering food in Pittsburgh, and they had to be pulled off the road because they failed to do something that an intelligent human could do. They could drive to wherever they were going. That was not actually the hard part. The hard part was if they got to an intersection, they just sat in the little curb cut here. And so other people need to use the curb cut, right? And they didn't realize that. It's just one of the many, many different little problems you could run into in the real world that accessibility sort of brings to the fore. So there was a wheelchair user that was trying to go across the road the other way, and they couldn't get up the ramp because the robot was there. The robot doesn't move out of the way. It might stop if it's concerned it's going to hit somebody, but it doesn't move out of the way. And so this got me thinking, I think one of the big challenges in developing systems for real is, how do we design for ability outliers, right? So this is just a random distribution, but there's a lot of people out here, right? If you imagine this somehow is people, and it's hard. It's hard in an ML world to do that, right? Because you don't have enough data, right? So how do you do that? Well, maybe we could collect additional data. We could oversample. And trying to predict in advance, the unknowns is obviously really hard, the unknown unknowns. And so what do we decide then makes a solution viable, right? So how many people does it need to work on? How do we avoid those mistakes of the past where we've locked into a certain set of abilities that matter and a certain set that we'll deal with later? Yeah, so anyway, so some concrete ideas here. I think that discovering these important problems and mapping them onto something that's computationally tractable, collecting meaningful data sets, designing interactions that make sense, all this sort of is in the purview of HCI, right? At least I think so. So here's some examples of problem definition and data collection. So this will be in dyslexia detection and visual assistance. So project I worked on with a postdoc, Luthrello, was dyslexia detection. Problem here is that there's a huge amount of kids, especially in schools, that have dyslexia, who don't know they have dyslexia, and as a result, the most common way they find out is they start failing in school. That goes on for a while, and then eventually someone maybe says, hey, I wonder if you have dyslexia, and then they go off maybe to get a $2,000 test, and so we wanted to kind of reduce that burden. Why I think this is not, this is a really hard problem, but at the same time, most of what was hard about it was figuring out what data to collect and then actually collecting the data. And so we, Luth mostly, who has a linguistics PhD and knows a lot about dyslexia, designed some exercises based on a bunch of prior work to elicit differences that she thought would elicit differences, and then collected a huge amount of data from about a few thousand people, many of whom had dyslexia, based on diagnosed tests, which is really hard to find, right? Because the whole problem is that you don't know for sure, and so you have to do all this careful screening to make sure you don't have people that actually have dyslexia who don't think they do. Anyway, lots of different things there, and built a classifier that used pretty simple machine learning to get a reasonably good precision recall for a test. And that test is now out in Spain. It's been used by a couple 100,000 people. There's Luth with all of some very famous people. You have to do a quiz about whether you can know who all those people are. And developing it into a training program as well, so that we can not just kind of detect, but also kind of use the detected strengths and weaknesses to then customize a learning program. Another data set collection, which I didn't even think of as a data set collection at the time, a project where we released this iPhone app that crowdsourced visual question answers. So a blind person could take a picture of something they wanted to know about, speak an answer, or speak a question, and then get an answer back from the crowd pretty quickly. And I'm just going to run through this. We got so many. We released this. We got, I don't know, I think it was ended up 180,000 questions or something. And they're just all over the map. You can ask me later if you want to see more examples, like interfaces that don't work. We got like fashion advice. We got broken computers. It's like, what does this thing say? My computer's broken and now the screen reader doesn't work. Right, so lots of stuff. We got a pregnancy test, so apparently there's not accessible pregnancy tests out there. And so after a while, and it took some work, again, here dealing with some of the privacy concerns, we were able to release this as a data set. We had a CVPR paper, and now we have a series of workshops at CVPR where we're challenging people. So there's already this really active community in visual question answering in the computer vision space. But now we have a real task for them. And it turns out that pictures are different. Like half the time, the thing they're asking about isn't in the frame. You know, they're blurry. It's really, really challenging. And you know, to the community's credit, there's actually been a lot of interest in this, which has been exciting. We also realized that one of, you know, in basically preparing this data set, one of the challenges is for making something like this work is helping people better understand whether they're revealing private information. And so we were able, again, with a lot of work, to be able to go through and create a data set of images with private information stripped out, so that then we could set up a second challenge of, can you predict whether this image has private information in it or not? Kind of interesting. This ended up getting into a couple products. So Microsoft Seeing AI, Google Lookout used our data set in part to train their models. One of the things, though, that it revealed to me is I think that I think that in our rush to do all these fancy things with AI, sometimes we fail to find the kind of limited scope, but practically really important problems that we could really make work. And so, you know, general solutions for visual question answering or image captioning still don't work all that well, right? So like Facebook released this, which is pretty cool they released it. You know, every image now that gets put on Facebook has some tags associated with it, so you can kind of understand maybe a little bit about what's going on. You know, two people, smiling, sunglasses, sky, outdoor, water. Obviously, you're missing some stuff, but you're still getting some context. But it's interesting when they make mistakes. So Mary Morris at Microsoft has this great example of, you know, Hillary Clinton getting onto the stage, and it says, you know, I am not really confident, but I think it's a man doing a trick on a skateboard at night. And then they interviewed some people who were blind, and they said, well, why do you think Hillary Clinton would put that on her webpage or Twitter feed or whatever it was? And they said, well, you know, she's probably trying to appear young and hip and whatever. So it could be very confusing, right? Whereas some other problems, I think we can actually pick them out so that they can work very reliably. So one thing we've been looking at, which even I was surprised by how much attention there was about this, but making memes accessible, and this is kind of the old school memes. We're starting there, you know, moving forward. What's really nice about this is it's a very narrow problem. There's only so many meme templates. The text is always impact bold, right? So you can make this work very, very reliably, right? And so one thing is to just, you know, make it accessible in the sense we described the meme template and we say what text it is. We've also been working with, you know, more of a design process with participants about, well, what would be a more first-class version of meme accessibility? So I think I have an audio clip. If I don't, I'll be really sad.
Put candy bar in shopping cart without mom noticing.
So that's sort of like Success Kid made audio with a little, you know, some audio sound effects. Other thing, even from the VizWiz data set, like it seems very large, and it was very large in scope, but we noticed some patterns, right? There's all these real world devices. So there's like all these appliances that none of them have accessible interfaces, like I mentioned this, but so we made a system that, you know, uses some crowdsourcing plus then computer vision to give feedback, and we're able to, you know, make vending machines and things accessible. You can imagine replacing some of this with OCR.
Near sample copy. Energy saver. Energy saver. 2. Yes. Yes. Dump. Near back. 8 and 7. 7. 8. 8 and 0. Stay. Left. Down. Down. Power. Near power. Power. Up. Down and up. Down.
I always like to end on the laser cutter, because I'm like, blind person using a laser cutter? I'm like, hell yeah, blind person using a laser cutter. With a little bit of extra work and we actually put a dollar bill next to the interface to get a real size. We're able to compute a 3D model of this. And so again, kind of the spirit of, translating it to new modalities, we're able to go into, a fabricated tactile version of the interface. We send this off to 3D hubs to get printed. And then here's a blind participant going through the process of actually using this. So you take a picture of the dollars there so we get the right size stuff. They get a little bit of feedback about, that's a whole other problem. How can we assist people who are blind with photography? It's a little quiet. All right, she takes a picture. And then able to attach this. It's a little bit of work to make it so that it's aligned with some of the boundaries you can feel. And a lot of work that I'm not covering here about like, well, what material should this be so that it's reliable, robust, but you can actually push through it to the underlying buttons. So that. Touchscreens, there's a million touchscreens out there. None of them are accessible. They'll probably be around forever. We adapted some of the ideas from slide rule, but now we have this little 3D printed finger cap that you can now do risk-free exploration, where if it's a capacitive screen, at least it blocks your finger from triggering things. And then if you want to trigger something, depending on the design, you can kind of rock down and trigger it. Here's a participant. It's a little over the top in that there's all kinds of things going on, but I'll play the video.
What would you like to drink? Target. Hot beverages. Move down. Move right.
This is our kind of fake coffee machine.
No finger. Move left. Move left. Move left. Move up. Move up. Move up.
He's got his camera head mounted.
Press it. At hot beverages. Press it. At hot beverages. Press it. Move right. Stay. Hot beverages.
There's also this dialogue system that's working behind the scenes that was built up automatically from videos of, anyway, lots of stuff happening to kind of get over this legacy problem. Whereas if you imagine the coffee machine, if the coffee machine was accessible from the beginning, or used a platform that was accessible, if it was Android based or iPhone or iPad based, it would just be accessible. But because they're not, then there's all this work. It's an interesting tension. Okay, so I'm out of time. So. I really think there is this huge potential, though, and I don't think it's the hypey AI that sometimes gets the most press. I think that the hard work of using the tools we have for machine learning and applying them, discovering real problems, applying them to real problems, I think there's just this huge harvest, right? So the AI autumn harvest of things that we can do, and hopefully we can actually get over some of these hugely hard, long-standing problems in accessibility and otherwise, right? So without machine learning, we're not going to I think, get past the scale problems, the legacy problems, some of these fidelity problems of translating between different modalities. But I think there's a huge opportunity to make progress, and so I'm really excited about that. And so I have some ways that maybe HCI people in particular, right, might contribute to this through building data sets, right? So building data sets is hard, especially interesting, new, novel ones. Sometimes it means having a whole project designed just to get out in the hands of people so that you can get data back from it. And lots of other things, uncovering problems and all this stuff. So I'm going to end here. Thank you very much. Here's obviously a huge number of people collaborated on this, and I'll take your questions. Thanks. Yeah.
Why do you think the large companies that make the products that you showed, from the iPhone to microwaves, are not devoting the resources to develop it from the beginning, as you suggest? And is it a market, there's not the market there, or that they don't realize what the market is? And are there any companies that you think do a particularly good job or bad job of doing it?
Yeah, well, I think it's a really great question. There's a lot of things going on there. I have a lot of respect for Apple, who has done a lot. So the iPhones are accessible to the degree that that you saw there, although there's still challenges, right? So ensuring every single app is accessible, all these things. As to why companies don't do more, I think there's a million different reasons, right? Although I did allude earlier back to this idea of is accessibility of value or not, right? So it used to be kind of popular for people to make this economic argument. You have a certain number of people with disabilities. You have people who are aging, who in a variety of ways would start to benefit from accessibility features. I am less convinced that that's the way to go. I really think is this a value or not? There's certainly policy legal reasons why people might want to ensure that their stuff is accessible. So nothing that you would plan to sell to the to education markets will get passed without being, at least in theory, accessible. There was this great example of I think Amazon had tried to sell Kindles to all these universities, and they didn't have an accessible experience or a plan or anything. And so the Department of Justice basically said you can't use Kindles as your primary way of delivering textbooks. And so there are those reasons. Although it's amazing to me how people seem to really just resist this idea. So the Twitter example of hiding the adding alt text to an image down 3 levels of menus before you can even see that it's an option. Or recently, I think it's Domino's Pizza, just fought tooth and nail against making their website accessible. And if you look as a sort of reasonably competently technical person, what they were fighting against was adding alt text and making sure that there were on click instead of on mouse down, because on mouse down assumes a particular input mode like device, whereas on click can work on a mouse or with the keyboard or with other things. So I don't know why that kind of resistance exists. It is certainly the case that it is way harder to do accessibility after the fact. And so, and it's not that hard to get this basic stuff right. Like, I think it's fun, talking to lots of people about all these exciting new things we could do for accessibility. What kinds of crazy new modalities could we expose? What can we do? But we don't have yet a reliable way to get people to put alt text on images. That's been a problem for 25 years. 25? Anyway, 25 years. So I'm not sure. Yeah.
Related to that, what is your opinion, not as a lawyer, but as a professor or an Apple employee, or maybe not an Apple employee, of whether ADA requires this in interfaces, and where do you think this should be a legal requirement versus a value of a company? And I know we had this discussion years ago, but I want to see what your thought is on it now.
Yeah, well, it probably doesn't surprise people that a lot of the legislation is a little behind and probably hasn't completely grappled with that question. So Section 508 of the Rehabilitation Act says that government, anything used by the government basically has to be accessible. And that usually gets extended to public universities and other things. So anyone with contracts with the government, what exactly that means to be accessible, right? It's always a little bit, it's probably not that first-class experience that we'd love, right? But you have to have some way. So that's one part of it. The private companies, so far, my understanding is that in the high-profile cases where, which have always been settled, right, instead of decided, which I think actually frustrates a lot of people, high-profile cases, it tends to be that the court will rule that the online presence, store, or whatever else, is an extension of something physical, and therefore the ADA does apply. Once that happens, then the ADA seems to apply, and you can't exclude people. So I think in another high-profile case, Target, this is a few years ago, they had some offers that were only available on the website that I think you maybe had to redeem in the physical store. I'm not sure how it works. And then with a pizza shop, it's probably pretty similar, right? You've got the online thing that connects to this physical pizza shop. There was a time when we thought that we would get some more clarity on this. So in a prior administration, there was a little bit more momentum toward the Department of Justice putting out some actual guidelines, but we haven't seen that yet. Did you have a second part? Is that good? Yeah.
For instance, with regards to the lack of use of the alt text in Twitter, how do you think it factors in that people with disabilities are a marginalized minority group, and unlike other marginalized minority groups, such as those with different sexualities, racial and ethnic minority groups, who some are still waiting for their day, people with disabilities still lack representation in the media and in social and cultural understanding, so they're therefore very marginalized still, especially augmented by their lack of inclusion in technology. And how do you think that affects people's lack of adoption of that feature versus the technological readiness of its accessibility below the picture? And how do you think technology can drive their inclusion or people's awareness of the need to less marginalize that group?
It's a really fantastic question. I will say that one of the great things about working in accessibility is that I've gotten to work with a number of people who think about these issues much more deeply than I was ever prepared to do, and so I think it's a really important part of that perspective. I definitely agree that one reason why it's not out there more is that people don't seem to know that this is a thing. It's amazing to me, like, I was once requesting, accommodations for a student, and, we ended up talking to like a vendor, and the vendor's like, wow, no one ever asked me to. Clearly somebody, it was a big vendor, like clearly somebody else has had this problem, but it's not documented, it's not somehow out there. I don't know how we overcome that, but I definitely agree that it's part of the equation, right? So, you mentioned kind of policy. I am very squarely in the technical side of things, and I think advocacy is this, the other kind of leg of the stool to make this actually work. But I don't have great ideas about how we do it. People do band together on social media. I think it's one of the ways you can kind of point at successes where you can get people that are more geographically dispersed to kind of come together around certain issues. But it certainly hasn't solved everything.
That's for sure.
Great question, thanks. Yeah.
Last question.
Last question. So you did present a little bit of crowdsourcing as an alternative where other humans are like man in the middle or like human in the loop. Mm-hmm. Couldn't we make this more like a social discussion? I mean, right now it's a machine-human interface discussion, and that's important, but we live in a society with a bunch of people. Should we start creating systems where humans are more active, supporting each other? And I'm not trying to imply anything that anybody wants to do or not. But clearly we are always looking for support from other humans. And now we're basically in the machine, we're doing all these very complicated techniques to try to avoid, maybe with a human on the side it would have been easier. So, but I'm talking about a systemic approach, not just finding a kind soul that comes and helps this person.
Yeah, no, I think it's a really great question. A lot of the work that, say, Michael was alluding to was very much oriented toward making those connections, right? And whether that's paid crowd workers, or we also had systems that would connect volunteers on Twitter to do different things that you could do remotely. One of the bits of recent work that I really like and I've taken inspiration from is from Cynthia Bennett, who is at the University of Washington, actually at CMU with me now as a postdoc. But she has this model for thinking about disability called the interdependence model, which I think is really useful in kind of breaking down that assumption of complete independence being the end-all goal, where I know why people strive for that, but if you look around, none of us are truly independent of each other. And so more clearly kind of recognizing that and building from that in ways that respect people's autonomy and agency and all of these things, I think is a really fruitful way to move forward.
All right, let's thank Jeff.